Hi everyone. In this video we're going to continue talking about the topic of permutations. So we are talking about counting things, and we're counting arrangements of objects in a certain order. In the last video we talked about arranging where we used all of the available objects. So we did one example with Santa's 8 reindeer, arranging all of them, or arranging the 12 teams in the Big Ten Conference, and we used that factorial notation. In this video, what I'd like to do is develop the formula with you for permutations where we're only choosing some out of the available objects. Alright, so here's an example. How many different ways can a pledge class with 20 members choose a president, a vice president, and a Greek council representative? No pledge can hold 2 offices. So this is your clue that's letting you know that there is no repetition. Okay, we're not repeating people. And then here we're using a different meaning of the word order. We're using it to represent the differences between these 3 different roles. All right, so like if we chose person A for president, person B for vice president, and C for the representative, that's different than if we switched things around and had B as the president and A as vice president. All right, so there's an implied order or just like a distinction between those different offices. Okay, so how many different ways are there to do this? Well, let's go back and use the fundamental counting principle to begin with. We are choosing 3 different offices. That's like 3 different events. And then we just want to see how many ways there are to make that choice. All right, so for the president, vice president, representative, president, we have 20 different members to choose from. So there are 20 different options. Now, since nobody can hold 2 offices, that means then there are only 19 people left for vice president once we've picked a president. And then there would only be 18 people left for the representative. Okay, and then if you multiply those together, that should give you the number of options possible. Okay, and I get 6,840 options. Okay, so you might be wondering, well, like, why do we even need a formula? Why can't I just do this every time? Well, let's say that this was a question with 200 people, and you were choosing or arranging 40 of them. All right, so what you'd have to do is sit there with a calculator, start with 200, and then multiply by 199, 198, 197, etc., and you would have to keep going, and you would do that for 40 different numbers. So that's a bit tedious, and it would be nice if we had a formula that kind of worked all of this out for us, something that you could just punch into a calculator. So that's where we're going with this. Alright, so hang on to that example, 20 times 19 times 18, and we'll come back to that one. Here's another one. In how many ways can a manager and an assistant manager be selected from a department consisting of 10 employees? Alright, so here we have 2 choices to make, manager and assistant manager. We have 10 people that could be the manager, and then assuming that one single person can't be both of those 2 jobs, then that would give us 9 people left for assistant manager. Alright, so 90 different options. Alright, so let's try to work to a formula. Alright, this is sort of a permutations problem, just with sum out of the total options available. Okay, so our first problem was like 20 people, and we wanted to arrange 3. And we knew that that was 20 times 19 times 18. And the second problem, we had 10 people, and we wanted to arrange 2 of them, and that looked like 10 times 9. Alright, so first of all, notice this is sort of similar to a factorial. If we did 20 factorial, that's 20 times 19 times 18, Okay, but then it just keeps on going all the way down to 1. And what we really want to do is have a formula that says, okay, well, let's cut this off. Let's stop when we get to 18 instead of continuing on all the way down to 1. For the other problem, 10 factorial is 10 times 9 times 8 all the way down to 1. But what we'd like to do is just stop after the first two numbers and skip 8 all the way down to 1. All right. So how do we get rid of those numbers? Well, you may have seen or noticed in the previous examples when we did division with factorials that division canceled out some of those numbers. All right. So if I had, we'll do the second example, if I had 10 factorial and I divided it by 8 factorial, that's going to divide by 8 times 7 times 6, etc., all the way down to 1. Sorry, glitch there. That leaves me with just these first two numbers that I wanted, 10 times 9. All right, and for the 20 factorial, if you divide by 17 factorial, that gets rid of the unwanted numbers, 17 all the way down to 1, and leaves you with just the first 3. All right, so we're getting close to a formula here. Then what we need to do is just make this a little more abstract. So instead of specific numbers, we want a single formula that works in every situation. All right, so if I call this first number n for like the number of options available, and then if I call this second number r for, and that represents the number that we're choosing or arranging, putting in a certain order, okay, then you can see that the formulas I've started to develop, this one, that's n factorial over something factorial, right? And what I need to do is just figure out a formula that represents that 17. Right? And here, 10 factorial, 10 is n in this situation, and then I need to figure out what I can put in place of the 8. All right, so how do we get 17 out of the numbers that we have? All right, well, you've got a 20, you have a 3, so notice if you subtract those 20 minus 3, that gives you 17. And over here on the right, if you do 10 minus 2, that gives you the 8. So for the denominator of the formula, this would just be n minus r. And we put it in parentheses to show that we subtract and then do the factorial. Okay, so this is a formula, and then we just put a label on it. There's a calculator key. If you have this on your calculator, it looks like NPR, right? And this stands for P for permutations. This would be a formula for the number of permutations of n objects where we're choosing r of them. All right. So here you go. Here it is written out with a definition. And let's practice using this. All right. So let's say we had 5 and we wanted to arrange 3 of those objects. All right. So if you had like 5 people and you wanted to arrange 3 of them in a line, then that should be 5 times 4 times 3, or 60. All right. But now you have a shortcut if you have this key on your calculator. So what you want to do is just type in the 5 and then that key NPR, and you're going to find that in a similar spot to where you found the factorial symbol. All right, so look for that. And then you hit the number 3. All right, and then that should give you the same answer, also 60. If you're doing this by hand, this is how you use the formula. All right, the part on the left here is just sort of like a label, and then the part on the right, you would fill in the numbers. So this would be 5 factorial, right? 5 is n, and then the denominator would be 5 minus 3 factorial. All right, that's 5 factorial divided by 2 factorial, right? And that's 5 times 4 times 3 times 2 times 1 over 2 times 1. The 2's and 1's cancel, and 5 times 4 times 3 is 60. Alright, so that's the long way to do it. I wouldn't suggest that unless you don't have access to this calculator key, but you're probably going to want to use that if you do have it. Okay, so here's another example. Solving a permutations problem. In a lottery game, 40 numbered ping pong balls are put in a bin and 4 are chosen at random, one at a time. To win the game, players need to match all 4 in the order in which they were drawn. How many different winning orders are there? Alright, so first of all, this is a problem talking about order, so it is a permutations problem. Alright, we need to make sure that there is no repetition. No repetition in order to use this rule. Okay, so these are some clues about what to look for. And let's see, this one, it looks like we're just drawing the balls without replacing them, so you wouldn't be getting, 2 of the same ping pong ball. Alright, so then the question would just be, if you wanted to use this key or this formula, what is n and what is r? So n represents the total number of available objects. So here we have 40 ping pong balls. And then we want to arrange in order how many of them. Alright, well we're choosing 4, so that represents r, the number of things that you're choosing. Alright, so it's always the larger number goes on the left, smaller number on the right. Okay, so calculate that, enter that in, and the answer is 2,193,360. Okay, quite a few ways to arrange 4 of those ping pong balls. Here's another one. How many 6-letter passwords are there that use only lowercase letters with no letter repeated? Alright, so first of all, is there an order here? Is this even a permutations problem? Okay. Well, it's implied. We're talking about a password, so the order of the letters would make a difference. If you have a different order, it's a different password. Right? So then we need to decide how many options there are possible, and then how many we're going to choose. Right? So it's a 6-letter password, so we're choosing 6 letters. And how many options do we have to choose from? Well, we're using lowercase letters with no letter repeated. So this problem's written in English, so we'll assume that this is the English alphabet, and that means that there would be 26 letters to choose from. Okay, so then you need to just enter that on a calculator. All right, and 26, arrange 6 is another large number. Okay, it's, let's see, 1,657,65600. All right, so 165,765,600 options. Okay, so some things to check for. Is this a permutations problem? The formulas for permutations are used when we're looking for the number of ways to arrange objects when the order matters, and once an object is used, it can't be used again. Okay, so order and no repetition. Okay, in this video we've talked about that formula, NPR. Right, remember from previously, you know n factorial, and you also know the fundamental counting principle, where you just multiply things like 5 times 3 times 2, etc. Alright, so keep those in mind. Go back and review if you need to. And that's it for permutations.